This is the first of 3 videos where I'm talking about circles. This time I'm talking about circumference and area. Next time, arc length and sector area. Third time, the circle formula, the one everyone hates. Okay, so circumference of a circle is like the perimeter of the circle. It's how far around a circle is. Area, of course, is how much grass you'd have to cut if you had a circular yard. And that's really what there is to it. Now, there's a lot of confusion about these formulas, and I love telling you that, doing a lot of videos. You don't have to know this formula, just kind of remember it works this way. Doesn't work here, unfortunately. You have to know these two. And we'll try to give you a couple tricks to help remember it. This will be our circumference circle, and then we're doing 2 ACT problems. One's at the bottom of your screen. The second one will also be in the bottom of your screen, but it involves 2 circles, hence like the little bullseye thing going on here. So this will be our circumference circle. And circumference you can say is equal to 2 times pi times r, or a lot of you have learned it as pi times diameter. Area, we'll put it down here. That is a lousy arrow, try again. Area is equal to pi r squared. Now let's focus on the top one of these and this. You'll see that there are 3 things in both formulas that are the same. 2, pi, and r, right? The only difference is where the 2 goes, okay? If you've ever bought carpet, tile, hardwood floor, well, been dragged along with your parents most likely or someone else, paint, anything like that, talk about square feet, cloth, fabric, whatever. Lumber, square feet. So when we find the area of something, we find how much it covers in 2 dimensions, the x dimension and the y dimension. Circles are actually, even though I think they're one of the hardest shapes to work with, certainly one of the hardest to draw. They're one of the simplest shapes in nature. Like if I stick my hand on the top of my head like this and spin around in a circle, I've completely described a circle. Right? I mean, assuming that my hand could cut through the wall, which is something I'm working on. But in a rectangle and in triangles and stuff, we have like 2 things we can do. We have like length and width, or like base and height, right? But in circles, we only really have that 1 dimension. So how do we get to square units? Remember, areas in square units, square feet, square yards, inches squared. Well, we have to square the radius. We have to square the radius. In this case, we're just multiplying the radius by 2 because the radius is half the diameter, so 2 times the radius is the diameter. Diameter times pi just tells us how far a trip it is around the circle. When we square the radius, it tells us how big that circle is. All right, that's just a trick to remember it. Hope it helps. Let's look at our first ACT example, the one on the bottom of your screen. This is a kind of a classic format for these questions. You know, they're not going to make it super easy. So you're combining the skill of knowing the circle formula, knowing the circumference formula, with also being able to plug into an equation. So it's set up like this. They tell you this is the radius. It's almost an unnecessary diagram, right? Doesn't do anything for you to help. Has a circumference of 25. Put everything on my diagram so I can be done with the question. Okay, and I want to know what the radius is. All right, what I'm looking for. Okay, so my circle formula equals 2 times pi times r. Well, I plug in what I know, 25 equals 2 times pi times r. And then I solve for r. So it'll be 25, 2 times pi is roughly 6.28. Right? It's a decent approximate answer. And they want to know approximately how much it is. Well, 6 goes into 24 4 times, and it's like 4 1/4, so the answer is going to be 4, give or take. That's all there is to it. What do? Knew the formula, no shortcut around it. Just remember the 2 goes in front. It's not square because it's not radius, or excuse me, an area. And we just plug in what we knew and solve for what we didn't. Let's look at the second one. And switch the screen out here. Oops. Okay, now I got my second one up. There are two circles, A and B. A has a radius of 1. So A has a radius of 1. And B has a radius of 2. It's a radius of 2. Twice the radius. What is the ratio of circle A's area to circle B? So whenever I have a ratio question, I'm going to start by setting up that ratio in plain speak, just so that way I don't flip it later. There's usually a wrong answer choice for that, although I don't think there is on this one. So I'm looking for A to B. Now it's tempting to say 1 to 2, right? But look at it for a second. Like, you know, this, yeah, like you can see, like, yeah, this is kind of like half of this, like distance-wise, right? But don't you figure like this big donut, right? Including circle A. Let's actually move circle A out just for a second, because that can be misleading. Move circle A out. I've done better. Don't you figure this? And of course, this one isn't drawn to scale. This has less than half the area of that, and it will. If you remember your rates and conversion stuff, I told you convert first. Why do you convert first? Because if you don't, and you're finding area or you're multiplying things, your conversion factor needs to get multiplied as well, right? There's 4 6x6 tiles in 1 square foot, even though there's only 2 6-inch increments in 1 foot, right? Because you have 1, 2, 3, 4. Check out the video for more on that. Okay. So there's no other way to do this than to plug in, right? So I know that area of A is equal to pi r squared. So that's the area of A is equal to 1 squared times pi. So area of A is 1 pi. Now I would just leave it in terms of pi, because at the end I'm going to be comparing them. So, you know, the pi's are just going to kind of cancel off. Area of B, still pi r squared, right? But now I have 2 squared times pi. So B is 4 pi. Remember, ratios are fractions, so I can say this is 1 pi over 4 pi. I can cancel my pi's if I want. It's just one way to think about it, but I can cancel them because they're essentially, we're just simplifying this, right? Both have pi's. Pi's both a factor. All right, so the ratio of A to B is 1 to 4. That's all you need to know. So remember this. Remember area square units. You have 3 things in both the circumference and the area formula: pi, radius, and the 2. Area square units, that 2 needs to be a square. Check out the video on sector area and arc length, because that shows up quite a bit and it really throws people for a loop.